numbers again, like this other time. Today we are looking at numbers in standard form. It's either we call it standard form or we call it scientific notation. And most often we use to write numbers that are very, very small or numbers that are very, very big, large numbers in this notation because it's very convenient when we work in that form. For example, if I say the budget of Nigeria for this year is 6,500,700,000,000, and I have this. This is 6,500,000,700,000,000. Writing this is cumbersome. Now, in order to write this and still make sense out of it, then we employ what we call writing numbers in standard form. This, you will need to start counting the numbers of 0 to know if you're right or not if you're writing in this form. But what do? You just write it in standard form. And when we are writing numbers in standard form, it is always of this form. We have A times 10 raised to the power of n. A is a number between 1 and 10. N is an integer always. It could either be positive or negative integer depending on the number we're dealing with. Now, A is always between 1 and 10. A can either equals to or greater than 1, but A cannot equals to 10. A is between 1 and 10. It must be equals to 1 or greater than 1, but it must not equals to 10. Now let's see what we have here. Let's see how we can actually manage what we have here. Let's talk first and foremost about the powers of 10. Let's look at those numbers and let's look at powers of 10. Number and if, for example, we have 1 million, this is 10 raised to the power of 6. If we have 100,000, this is 10 raised to the power of 5. If we have 10,000, this is 10 raised to the power of 4. If we have 1,000, this is 10 raised to the power of 3. If we have 100, this is 10 raised to the power of 2. If we have 10, this will give us 10 raised to the power of 1. And if we have 1 is 10 also raised to the power of 0. From our last class, we know that any number raised to the power of 0 equals to 1. Also, if we have number less than 1, 0.1, this is 10 raised to the power of negative 1. Negative 1. If we have 0.01, this is 10 raised to the power of negative 2. And so on and so forth. We will be in need of this, we'll be needing this. Now, mind you, for easy accessibility, how do I know the power that each of these 10 will be carrying? Simple. It is just the number of zeros we have behind it. Like here we have in 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 1. And here we are not having zeros at all. 0. Here we are going to be counting the number of places of the decimal we have before the number. Here is just 1, but then that would be in the negative sense, -1, and here we have 1 and 2. That is the reason why we have the -2. And it continues downward also that way. Note always that m for numbers greater than 1 is always positive, while m for numbers less than 1 is always negative. Let's look at some example. And we use a number that will help us to quickly grasp what we have been discussing since. Let's look at 500, 50, 5, 0.5, 0.05. Let me say also that our A must be in at least one decimal place. Our A must be in at least one decimal place. So, if we have 500, what will 500 equals to? 500 will equals to 5.0. Do not forget that I say our A must be in at least one decimal place and times 10. Now, let's see how we're going to deal with this. What will be our m in this situation? What will 10 raise to? To know what 10 will be raised to, let me quickly say this, that there is, in this 500, we do not have decimal points, so to say. But then let me say to you that there is an imaginary decimal point that we have behind this 500. So what we are looking at now is, we are looking at this decimal point moving 1, 2 places, which will now make it to be right behind 5. Then we'll put just 1 0 there. Then what we have here will be 5.0 times 10. Now, this decimal point has actually moved how many places? 1, 2. That will be the power that this 10 will be carrying. Now, let's look at 50 and do the same thing. If we have 50, there is this imaginary decimal point behind the 8, which will move just a place. Then that will give us 5.0. So this will equals to 5.0 times 10 raised to the power of 1. Beautiful. Let's look at 5. For 5, the decimal point is right behind it. So, is the decimal point going to move at all? Beautiful. No. The decimal point will not be moving. All what you just need to do is just for us to add a 0 behind it. That 0 is insignificant. Hope you know that. So this will give us 5.0 times 10. Since the decimal point is not moving at all, what will be the power? 0. Beautiful. The power there will be 0. Now let's look at numbers less than 1. We have 0.5. The decimal point now is moving in the opposite direction. It's moving towards the right. So the power in that situation will be negative. Now let's see how many places this decimal point will move now. It's going to move from here to this point. So what we're going to be having now will be 5 points. Then we just add the 0 to it, which we know that is insignificant. That will give us 0.50 times 10 raised to the power of -1. Here we have 0.05. 0.05 equals to, what would that give us? This decimal point will be moving, and we know it's moving towards the right, so it's going to be negative. So it's moving 1, 2. It's moving 2 places. That will be 5.0. We're going to have 5.0 times 10 raised to the power of -2. For this, we see from 555, 0.5, 0.005, they all have the same A. just 5.0, 5.0, 5.0 all through. But then the distinguishing factor here is the power of 10 that we have here. The power of 10 is the one distinguishing, telling us that this is not the same thing as this. Telling us that this is not the same thing as this. The power of 10. That's the only difference that we have in all of them true. And that is what is distinguishing the numbers for us. Now let's look at some other examples. Let's look at 4.35. If we're given something like this and we're to write this in standard form, what do we do? How do we approach it? The first thing we want to ask ourselves is, where is the decimal point? How many places will that decimal point be moving to actually have a number greater than 1 but less than 10? If we look at this number carefully, we'll discover that this number is between the range that we have specified our A to be. That is, it's greater than 1 and it's less than 10. That actually is telling us that this decimal point actually is not moving anywhere. What we just need to do now is, this will be 4.35 times 10. Now, what will be the power of 10? Has this thing moved at all? No. Since it does not move, we say it has moved 0 places or 0 places. Yes, sir. So that will be raised to the power of 0. Let's look at this. 0.00067. This is not a number in the range to which we have specified our A. So what do? We need to ensure that we have this number in the range that we have specified our A. That means this decimal point will be moving, but this time it's moving, shifting towards the right. So definitely it's going to be a negative index. So let's see what will be that number. It's going to be from here to here, that's 1. From here to here, 2. From here to here, 3. And from here to here, 4. So what we're going to be having now will be 6.7. 6.7 times 10. 10 raised to the power of -4. Because it has moved from 1, 2, 3, 4 places. More examples. If we have 1, 2, 0, 2, 0, 0, 0. If this is the number we're having, and we want to write this in standard form. Mind you, remember I said earlier that there is a decimal point right behind it, even that we don't always show. This decimal point needs to move in order to give us number that will be suitable for A, number greater than 1 or less than 10. Then that means this decimal point will need to move to the left now. So if it's moving to the left, you know the index will be positive. So it's going to be 1, 2, 3, 4, 5, 6. That will give us 1.202 times 10 raised to the power of 1, 2, 3, 4, 5, 6 raised to the power of 6. Now you'll see that it's convenient to write numbers in this form than writing it in this form. It's more compact and it's more presentable than when you have zeros or you have a very long numbers, and when you're copying it or when you're looking at it, you might actually skip some things. You might actually skip some zeros unknowingly. That's the reason why it is beautiful for us to always write our numbers in standard form. Let's look at this. What happens if you're given a figure like this? 067. Examiners can give you a figure like this and they will still ask you to write it in standard form. Now the question comes in. Let me ask that, is this 0 that we are having here, is it significant? Oh, beautiful. It's not significant. The 0 we're having before the 6 is not significant. This number is the same thing as writing 6.7. So don't allow that to confuse you at any point in time, because this 0 is not significant. So we are just given this number and we have to write it in standard form. So how do we write this in standard form? What we are having here is a number that best fits our A, number greater than 1 but less than 10. So that tells me that this decimal point is not moving at all. In that situation, we have 6.7 times 10 raised to the power of 0, since our decimal point is not moving from where it has been earlier. Yes, let me quickly respond to the two questions that has been asked. Now, the first question is, why is it that if that decimal point is moving, why is it not stopping here? Now, let's look at that and see what will happen. Let's quickly check that. If we have 1, 2, 0, 2, 0, 0, 0, with a decimal point here, and this decimal is now moving 1, 2, 3, 4, and it's now stopping here. That means we're going to have 1, 2, 0.2. Is that clear? Beautiful. Then times 10 raised to the power of 1, 2, 3, 4. Now, the reason why this will not be fulfilling what we have been talking about is this should be forming our A. This part should form our A according to what we have here. And our A must be a number between 1 and 10. Our A must always be between 1 and 10. But the number we have here, this is 120.2. Is 120.2 between 1 and 10? Beautiful. No. So that's the reason why we cannot stop here. We cannot stop here also until we get here. That will give us a number between 1 and 10. That's the first question. Thank you. Now the second one. 06.7. Why is 06 not greater than 10? Why is 06 not greater than 10? Why is it less than 10? Now, why is it less than 10? When we look at it, okay, why is 06.7 not less than 1? Why is 06.7 not less than 1? If you look at it carefully, what will determine the number we are dealing with is their place value. The place value that we are having in this number, this is tenths. This is units. So what we're having here is 6 units, and what we're having here is tenth. That means we're going to have, if I'm going to write it for you like we used to do in primary school, it's going to be TU, then we have the tenths here. So under the tenth we have 7, under the unit we have 6, and under the tenths we have 0. Tenth says we're going to be multiplying whatsoever we have here with 10. 0 times 10 we see equals to 0. Unit says you're going to be multiplying whatsoever you have here with 1. 6 times 1 will give you 6. Now if we're going to add them together, we're going to be having the first one, which is 10 times 0. The second one is 1 times 6. And the third one will be 0.1 times 7. So when we are adding this together, this will be 0, this will be 6, and this will be 0.7. Adding everything together here, that will equal to 6.7. Now, that is showing us that this 0 that we have here actually is insignificant. It is not the same thing when we have 0.6. 0.6 actually is telling us that what we have here is a unit, what we have here is a tenth, which is not giving us the same value according to what we have here. So please take note of that. Here we have 307. 307. This will equals to, remember that the decimal point actually is right behind it. As long as they are not writing it in the number, it's definitely behind the number. So in this situation, this decimal point will be moving 1, 2 places, because this will be the only number that will be giving us a number that will be satisfying A, greater than 1, less than 10. If we should stop here, that would be 30.7. 30.7 is definitely greater than 10. So in this situation, we're going to have 3.07 times 10 raised to the power of, it's moving to the left, that means it's positive, and it has moved 2 places. That will be raised to the power of 2. 3.07 times 10 raised to the power of 2. In a situation where we're given numbers in standard form and we're to write them in the ordinary form, what do we do? Now, all what we're just going to do is just the reverse of what we have been dealing with so far. Now, let's look at it carefully and see some example. If, for example, we have 6.02 times 10 raised to the power of negative 2. This is what we're given. And they ask us to write this number in standard form. In ordinary form. Note one thing first, the first thing first. What we have here is negative 2. Negative there is making us to realize that that number is less than 1. It's a number less than 1. So, in that situation, we will be counting the decimal point now to the left. You remember that whenever we are counting towards the right, that is when we're converting it to the standard form and we're moving the decimal point to the left. You understand? That is when we're going to have negative. But now, since we are reversing it, it's going to be going towards what? To the right now. Okay. So we have this. Come back and write 6.02. Like I said, that the decimal point now will be moving, and it will be moving towards this direction. 1, 2. The decimal point will be here now. And we'll be supplying some things that are missing. What are those things that are missing that we're going to be supplying there? Zeros. Thank you. So we have 0 here, and automatically we put 1 0 here, and it's going to give us 0.0602. That is that number in the ordinary form. Let's look at another example. We have 7.8 times 10 raised to the power of negative 3. The same thing in this form. Let's see how we're going to be writing this. That will be, write your 7.8 out. Then let's try to move it. Remember, this will be going towards the what now? Since it's negative, it will be going towards the left. So it's going to be 1, 2, 3. Here is going to be where we're going to have our decimal point. Then we'll supply those things that are missing, which is 0, 0, and 0. So what we have here now is 0.0078. Okay, more. When we have 9.753 times 10 raised to the power of 4. This, because it's positive, it will be moving towards the right. So we're going to be having 9.753. Then let's allow our decimal now to move, and it's going to be moving how many places? 4 places. It's going to be 1, 2, 3, and 4. It's going to be here. So we just need to add one more 0 to this to give us 97530. That's the number there. Also, when we have a number like this, 4.658 times 10 raised to the power of 2. 4.658 times 10 raised to the power of 2. Let's write the number out. We have 4.658 raised to the power of 2. It's telling us that it's a positive, is greater than 1, and it will be going towards the right 2 places. That is 1, 2, and this will equals to 465.8.